Hello, class. How are you guys? My name is Mr. Contreras. Today, we're going to go ahead and go over an eighth grade standard. With the main is in expansion and equation, cluster B, standard number 5, which is graph proportional relationships, interpreting the unit rate as the slope of the graph. Okay, today we're going to go ahead and learn about how to understand slope as a unit rate, which tells us how fast something is changing. Man, that might just sound confusing. Slope as a unit rate. What in the world does that mean? We will connect this to real life by looking at how speed or rate works in situations like sports and movement. All right. So I'm going to connect this. There's different ways to connect this math lesson to real life, but since I'm a football coach and I'm a head wrestling coach, I'm going to show you how I apply it inside the wrestling room when I'm training athletes. Athletes are often expected to perform at a constant pace. If they go too fast or too slow, their performance can suffer, and if they go too fast, they may get tired and not perform at their best. That happens all the time in sports, right? So they need to go ahead and have a constant pace, usually in all sports that they do. Since I'm a wrestling coach, I'm going to connect this to how we train in the wrestling room. And in every wrestling matches, there's 3 periods in a wrestling match, and there could be overtime. So I'm going to break it down and in a way that we could understand this, so you can understand this. So I'm going to go ahead and use the example. Let's say a wrestler is running laps at a constant pace. So let's say he runs 1 lap, takes him 2 minutes to run it. 2 laps, 4 minutes. 3 laps, 6 minutes. 4 laps, 8 minutes. What do you notice about the time is changing? But what do you notice about the time? Good. In real life, athletes might slow down or speed up, but today we are focusing on constant rate to help us understand slope. And yes, you are correct. It goes up 2 minutes every single time they run an additional lap. Let's take a closer look at what's happening here. That way you guys could go ahead and understand it. When I look at the number of laps and the time, I notice that the number of laps increased by 1. So every 1 lap, the time increases by 2 minutes. Let's break that down step by step. From 1 lap to 2 laps, the time goes from 2 minutes to 4 minutes. From 2 to 3 laps, the time goes from 4 minutes to 6 minutes. From 3 laps to 4 laps, the time goes from 6 minutes to 8 minutes. What did you notice about the time, how the time is changing? Yes, it's always increasing by 2. By 2 minutes each time we take an additional lap. That tells me, and remember these words, that tells me this is a constant rate of change. What is it? Yes, constant rate of change. In math, when something is increasing at a constant rate, we call that a proportional relationship. What is it called? Proportional relationship. That means the relationship between laps and time stays consistent. Now let's connect it to some important vocabulary. Now, pay attention to these vocabulary words because it's really important. The amount of time increases each time, 2 minutes per lap. It's called unit rate. What is it called? Correct, unit rate. The unit rate tells us how much for 1 unit. What is a unit rate? It tells us how much for 1 unit. In this case, for every 1 lap, the time increases by 2 minutes. Okay, so the unit rate is 2 minutes per lap. Another word we use for this unit rate is slope. Slope tells us how fast something is changing. So in this situation, the slope is 2. Let me say this in a simple way. For every 1 lap, the time goes up by 2 minutes. So the 2 is the slope. What is the slope? 2, the 2 minutes. Okay. If I ask you how long it would take to run 5 laps, how could you figure it out? Remember, 1 lap is 2 minutes, 2 laps is 4 minutes. All right, so we could add 2 each time, or we could just multiply 2 times 5. So yes, the answer would be 2 times 5 is 10. So it would take 10 minutes for 5 laps. Either way, you're using a constant rate to find your answer. Other examples, not regarding working out, we can go ahead and let me show you. For example, If same, we're not doing laps. Let's say you're buying a soda. One soda costs $2. Two sodas cost $4. Three sodas cost $6. Four sodas cost $8. All right. So the constant rate goes up by 2 every single time we purchase something. We could go ahead and do the same thing with other areas. Like, for example, if you drive, let's say it takes you for every 1 mile you drive, it takes you 2 minutes. 2 miles, 4 minutes. 3 miles, 6 minutes. 4 miles, 8 minutes, and so forth. Okay, so understanding the constant speed and the slope is still 2. So regardless, the slope is 2. This is why understanding slope and unit rate is important. So I want you guys to go ahead, and once we understand that, I want you to go ahead and look at my examples that I have here, so you can see this. So when we go ahead and we plot our numbers, all right. So for every 1 lap, we said it's 2 minutes. 2 laps, 4 minutes. 3 laps, 6 minutes. 4 laps, 8 minutes. We go and we give the number of laps the x value, which is the way we write it, x, y. So x would be 1, y would be 2, and so forth every single time we plot it. So when we go ahead and plot it onto a number graph, so for every 1 lap is 2 minutes, 2 laps is 4 minutes, 3 laps is 6 minutes, 4 laps is 8 minutes. So for every 1 lap, we plot it. We plot our first one for is 2 minutes, 2 laps, 4 minutes, 3 laps, 6 minutes, 4 laps, 8 minutes. And this forms a straight line which shows proportional relationship. You guys see the straight line is showing? All right, so for every 1 lap, it goes up every 2 laps goes up, and so forth. All right, so the way we write this is the equation is y equals 2x. What does y stand for? Y stands for the time, all right, and the x stands for the number of laps. So we need to go ahead and remember this formula because that's the formula that we're using. All right, the number 2 represents the slope in the graph. So it goes up. What's the constant rate that's always going up per lap? Okay. And so some of the key vocabulary words that I want you guys to remember is the slope, unit rate, proportional relationship, and the rate of change. And now, for example, I want you guys, I'm going to say a sentence starter, and I want you guys to finish it. All right. In this graph, or in purchasing a soda, or driving 1 mile, or in my case, for every 1 lap that the wrestlers ran, all right, it goes up by 2. So I noticed that. How would you guys complete that sentence? Good. I noticed that every time the number of laps increase by 1, the time increases by 2 minutes. Now, do you guys, in math, there's patterns. So I want you guys to, do you guys see a pattern? Good. The pattern is that the time is increasing by 2 minutes each time, which shows a constant rate. Now, here's the next one. Next, I want you guys to try to finish this sentence. The slope is blank because, remember what the slope is? Yes, you're right. The slope is 2 because for every 1 lap, the time increases by 2 minutes. Today we learned that slope represents the unit rate, and we can see it in real life, graphs and equations. All right. If 1 mile takes 2 minutes, how long would it take to drive 10 miles take? If 1 mile takes 2 minutes, how long would it take to drive 10 miles? Anybody? Yes, 10 times 2 equals 20. So yes, it'll be 20 minutes. How can you guys use this in real life? Sports, good. Yes, driving. Items at the store, good. That way you could guess what a certain amount's going to be. You could predict it, right? So good. So I want you guys to remember, in math, there's always patterns. Once you figure out the pattern, you'll be okay. Next week, we're going to connect the idea of graphing and comparing different relationships. All right. Thank you. Have a good day.